Today we're looking at the Reteach 8-4, our angles of elevation and depression. When you're looking at an angle of elevation, wherever your eyes are straight ahead is your horizontal line, and if you have to look upward or raise your eyes up, you're looking up, you have an angle of elevation. If you're looking straight ahead, that horizontal line, if you have to look down to see something, you're lowering your eyes or looking down, you have an angle of depression. Elevation going up, depression going down. So if you're classifying the angles on this Reteach as an angle of elevation or depression. In problem number 1, your horizontal line is the dotted line. You're looking up at an airplane, so you have an angle of elevation. In problem number 2, you're standing on top of a cliff. The dotted line is your horizontal line. You're looking down at a boat in the water. That is an angle of depression. If you're looking at the diagram, you have two people standing looking at a building. One person standing on the ground looking up at a guy on the roof looking down at the man on the ground. The man on top with angle number 3 is looking down. That's going to be an angle of depression. And the man on the ground looking up is going to be an angle of elevation. In problems 5 through 8, you've got a lot of different angles going on here. In the diagram that you're looking at, from the bird's point of view, looking down at the lighthouse, you can see angle 2 is going to be an angle of depression. From the lighthouse looking up at the bird, angle number 1 is going to be an angle of elevation. From the lighthouse looking down at the ship is going to be an angle of depression. And angle 4 from the ship looking up at the lighthouse is going to be an angle of elevation. On the back side of the page, we can solve problems using angles of elevation and depression, just like we can solve problems with angles in triangles. So if I'm taking a look at my picture, where Sarah's watching a parade from a 20-foot balcony, so she's up 20 feet. She's got an angle of depression of 47 degrees, and we want to know how far is she away from the parade horizontally. You're looking at that angle of depression of 47 degrees, and you know because of horizontal lines being parallel and the alternate interior angles that the angle inside my triangle is also 47 degrees. So you're using the idea of the angle of depression to identify what the angle inside my triangle is. If I'm looking for the length away from, no, we're not looking for that length, sorry. We're looking for the actual distance from her to the parade, that horizontal, not the horizontal line, but the hypotenuse. So there's my x. If I know that my opposite side from the 47 degrees, the opposite side is 20 feet, the hypotenuse is x, I'm going to be using the sine function. So you're setting up your problems just like we've been doing. Remember that SOHCAHTOA. So sine means opposite and hypotenuse. So as I'm setting up my problem, I know that the sine of my 47 degrees is my opposite 20 over my hypotenuse x. I cross multiply. I divide by the sine of 47, so it's like interchanging those two. And in your calculator, with your mode in degrees, 20 divided by sine 47 gives you about 27 feet between Sarah and the parade. If you're looking at question number 9, you've got an angle of elevation to the sun is 52 degrees. They've labeled that in your triangle. The tree is casting a shadow of 9 meters, and we want to know the height of the tree. So my height here is the x I'm looking for. Notice that that is opposite my 52 degrees. The hypotenuse is not involved in my problem. So if I'm looking at my SOHCAHTOA, I'm looking at opposite and adjacent. And I'm going to use my tangent function. My tangent is the opposite over the adjacent. So my problem becomes the tangent of 52 degrees is equal to the x that I'm looking for over the 9 meters that I have. In order to solve that, you're cross multiplying. So your x will equal 9 times the tangent of 52. And that's just a number in your calculator. If your mode is in degrees, so make sure that you've done that and have that mode of your calculator in degrees. And then I simply put 9 tangent 52 to the nearest tenth of a meter. That will be 11.5 meters. And you're done. If you're looking at question number 10, don't forget your SOHCAHTOA. If you're looking at question number 10, you've got a person snorkeling, sees a turtle on the ocean floor at an angle of depression of 38 degrees. She is 14 feet above the ocean floor. How far away is she from the turtle? So when you're looking at that 38 degrees, you also know that I have a 38 degrees here inside my triangle. Those are those alternate interior angles that make a Z or a backwards Z. With respect to my 38 degrees, my 14 is opposite. The x I'm looking for is my hypotenuse. Because of my SOHCAHTOA, I know I'm going to use the sine equal to the opposite over the hypotenuse. And I set up the problem with the information I have. So the sine of 38 is equal to 14 over the x that I'm looking for. Remember the shortcut rule. If the x is on the bottom, I'm going to end up moving these two, kind of like interchanging them. I will end up with a division problem. In order to find my x, I will have 14 divided by the sine of 38 degrees. And that's just another number crunching exercise in my calculator. Divided by the sine of 38 gives me 22.7. They want it to the nearest foot, so I'd probably round that to 23 feet. So the girl is 23 feet away from the turtle. On question number 11, they didn't draw me a picture, and it's really hard to do problems without a picture, so I want to go ahead and draw one. Jared is standing 12 feet away from a rock climbing wall. When he looks up to see his friend ascend the wall, the angle of elevation is 56 degrees. How high up the wall? That's my x. How high up the wall is his friend? So with respect to my 56 degrees, I have my 12, which is adjacent, and the x that I'm looking for is opposite. So I know I'm going to use my tangent function, because that TOA, T equals O over A. And when I set up that problem, I'm going to set it up as the tangent of 56 degrees equals the x that I'm looking for over the 12 that I have. In order to solve, I'm just going to cross multiply. So my x will be 12 times the tangent of 56 degrees. And again, that's just a number crunching exercise. 12 tan 56 gives me 17.79, and 17.79 is about 18 feet. So his friend is 18 feet up the wall. The last question that I have, question number 12. Maria is looking out a 17-foot high window, so she's 17 feet up. She's looking out a window and she's seeing two deer. The angle of depression is 26 degrees. They want to know what is her horizontal distance from the deer. And so when I draw that triangle, and I'm trying to figure out, with respect to that 26-degree angle of depression, what do I have? I have the side that's adjacent, that's my 17. That'll be my A side. I have looking for the side that's opposite. So again, just like in problem number 11, I'm using that tangent function because the tangent equals the opposite over the adjacent. And when I set up my problem, I'm going to say that the tangent of 26 degrees is equal to the x that I'm looking for divided by the 17 that I have. Again, in order to solve that, I'm cross multiplying. So my x will be 17 times the tangent of 26. And that's just another number crunching exercise. 17 tan 26 gives me 8.29. So we want to know how far is she from the deer to the nearest foot, about 8 feet.